Next we will discuss about unbiased positive shunt clipper and unbiased negative shunt clipper. Okay, na? So in that first topic is a positive shunt clipper. Positive shunt clipper. So here shunt means parallel. Okay, right. So this is the circuit diagram. Okay, why it is called as a shunt clipper? Because diode is connected parallel with the load. So that is why this type of circuit is called a shunt clipper. So this is the circuit diagram. Here we are going to give the input signal. So x-axis time period, y-axis is a voltage, input voltage, 0, t by 2, t, 3t by 2. Okay, so this is the input signal from 0 to t by 2 during positive half. Okay, so here positive half is giving to positive terminal of the diode, right? Positive half is giving to positive terminal of the diode. We know already if positive signal is giving to positive terminal of the diode, then diode goes to forward bias condition, which means diode acts like a closed switch. Diode acts like a closed switch. So in this condition, if this part is in closed condition, then total input is shorted to ground. Okay, this input is shorted to ground. Why? Because this is in a closed condition, closed switch condition. If it is in open condition, then this input signal is moving towards the output, towards the load, right? But here this diode is acts like a closed switch, so total input signal is shorted to ground. Okay, so 0 to t by 2, output is a 0. Input signal is shorted to ground. Why? Because diode is a closed condition, so output is 0. Next, during negative half, negative peak is giving to positive terminal of the diode, then diode is going to be reverse bias condition. Reverse bias condition means it acts like an open switch. Open switch. Open switch means this input signal is moving towards the load. So that is why whatever input signal is there, as it is, we got at the output from t by 2 to t. Right? Next, t to 3t by 2. T to 3t by 2, again same on positive peak. When positive peak is giving to positive terminal of the diode, then it is going to be forward bias condition, acts like a closed switch. Then total, then this in this condition input is shorted to ground. Obviously at this situation we cannot get the output. So like this, in this way we got the output. During negative halves only we are getting the output, positive peaks are the clipped off. Okay, so that is why this total circuit is called as a positive shunt clipper. Positive shunt clipper. So here we have to discuss about these two conditions also. First condition is V in greater than to 0. Greater than or equals to 0 means input is at a positive side. If input is at a positive side, diode is going to be forward bias condition, which means acts like a closed switch. If it is in closed condition, this input is going to be short circuit. So at the output side we cannot get the output. Understand? Next, V in is less than to 0. Less than to 0 means during negative half. During negative half, diode is going to be reverse bias condition. Okay, acts like a open switch. If it is open switch condition, obviously this input signal is moving towards the load. So whatever input is there, that is equals to the output voltage. V0 is equals to V in. Okay, na? So this is what about a positive shunt clipper.